Hi guys. I'm going to work out a problem with you all on complete dominance, our first teacher-led practice problem. Before we even get started, I want you all to grab a piece of paper or a notebook. Keep in mind that you can replay this video as many times as you need to help you understand. So if you look at my setup here, I have complete dominance. If we look at the problem, I'm just going to quickly read the problem, but it's right there in front of you. If a red and white flower were crossbred, resulting in 100%, and then it gives you a genotype of dominant R, recessive R. Explain what phenotype will be seen in the offspring according to the rules of complete dominance. So the first thing you want to do is ask yourself, well, what is complete dominance? And then if need be, you would reference back to the slide that is right before this one, where it talks about incomplete dominance, the dominant trait will always show. It will always mask the recessive trait. So let's go ahead and get started. So again, on my paper, I always like to have like organization and a setup. So if you look at the problem, it says if a red and a white flower were to mate. So the first thing I did was I wrote down the genotype and the phenotype. And I also have it down here just to help you out in case you forgot. So genotype is the genetic makeup. It'll always be represented by letters. Phenotype is how something looks, tall, short. Okay, so back to the problem setup. So it says if a red and white flower were to mate, so I already wrote out the code for red and then for white, right? And then down here, you don't have to write this, but this is just to help you, remember. So we have genotype is the genetic makeup, which will be represented in the letters. Phenotype is how something looks, because there are certain problems where we will ask you what is the genotype or what is the phenotype. So you have to get this in your head so that you don't get the problem wrong. All right, so let's go ahead and get started. It says if a red and white flower were to mate. So we have our Punnett square right here. So you can do parent 1 right here, parent 2 right here, or you can switch it around. It doesn't matter as long as you keep parent 1 together and parent 2 together. So the first parent is the red flower. So right here, I'm going to draw out what was given for me for red, dominant R, and then it says if a red flower is mated with a white flower. So for white flower, I was given recessive R and recessive R. And again, I'm not making this up. I'm taking it exactly from the problem. So this is why I think that your notebook paper is important, so that you can jot down all the information that you need to help you. Now let's go back and see what the problem wants. They want to know what would be the phenotype of the offspring. So everything in the inside, this will be your offspring right here. So in our Punnett square, as we learned last week, your dominant will always come before recessive. So an easy way to do it is you will cross from here to here, here to here. And then you'll do your cross from here to here, here to here. Dominant will always come first. Think about if you were in the jungle and you saw a big mountain lion or a little tiny rabbit. Which one will be dominant? The mountain lion, the louder one, the one that's always going to show. The little baby rabbit will be recessive. So let's go first. Dominant first. So we have dominant R, recessive R. Go up here. Dominant R, recessive R. Same thing here. Dominant R, recessive R. Here to here. Dominant R, recessive R. So now let's look at what the question wants again. So we have the parent 1, parent 2, offspring right here in the middle of your Punnett square. So we want to know what would be the phenotype of the offspring, right? So let's go down here to our reference. I love to keep a reference on the paper. So genotype, genetic makeup, will be represented by letters. Phenotype, how something looks, tall, short, freckles, toothless. However, for this problem, we want to know the phenotype, right? So now we're looking at our offspring, right? Here are our offspring, and we want to know how they look. So we go back to our original code at the top, right? And we're looking at complete dominant. So the dominant trait will always show. So here, our offspring will be red, because again, the dominant R right here shows you red. And when you're looking at complete dominance, remember, the dominant allele will always show. So go back to the problem again. So explain the phenotype that we would see. So our phenotype, we have 1, 2, 3, 4. That would be 100% red. And then just to help you out real quick, think about it as four quarters, 25 cent, 50 cent, 75 cent, $1. So you can kind of count it up like a quarter if that helps you out. So we have 4 quarters right here. That would be 100%. So 100% would be red.